Somewhere between the stars, entire worlds drift unseen, carrying secrets no sunlight has ever touched. Astronomers now believe these rogue planets may outnumber stars in our galaxy, rewriting everything we thought about space. But how does a planet become lost, severed from the warmth of a star, condemned to eternal darkness?
To understand these lonely worlds, we must first revisit the violent birthplaces of planetary systems themselves. In these chaotic nurseries, gravity pulls matter together, while collisions reshape entire worlds in brutal cosmic battles. Sometimes, these collisions don't just reshape planets, they fling them completely out of their home systems forever.
Other times, passing stars disrupt delicate orbits, tearing planets away like leaves in a cosmic storm. The result is a rogue planet, untethered, drifting endlessly through the freezing vacuum of interstellar space. At first glance, these worlds seem lifeless, frozen and forgotten, too cold to support anything resembling life.
But beneath that frozen silence, something unexpected may be hiding, something that challenges everything we assume about life. Scientists have discovered that some rogue planets could retain heat deep within their cores for billions of years. That internal heat might be enough to maintain vast underground oceans beneath thick layers of ice.
In our own solar system, moons like Europa and Enceladus already prove that hidden oceans can exist without... If moons can harbor oceans in darkness, could entire rogue planets sustain even more complex environments beneath their surfaces? This possibility has transformed rogue planets from cosmic debris into potential habitats, hidden far beyond the reach of stars.
But detecting these invisible worlds is one of the greatest challenges astronomers face today. Without a star, they emit almost no light, making them nearly impossible to see with traditional telescopes. Instead, scientists rely on gravitational microlensing, a technique that reveals objects by how they bend distant starlight.
When a rogue planet passes in front of a distant star, its gravity briefly magnifies the light behind it. This fleeting flash can last hours or days, but it's enough to confirm the planet's existence. Each detection is like catching a shadow moving across the universe, hinting at worlds we can never directly see.
And with every new discovery, the number of known rogue planets continues to rise beyond expectations. Some estimates suggest there could be trillions of rogue planets drifting silently through the Milky Way alone. That means for every star you see, there might be multiple invisible worlds wandering in complete isolation.
Some of these planets could be gas giants, massive and cold, resembling Jupiter, but without the warmth of a sun. Others may be rocky, Earth-sized worlds, potentially hiding oceans beneath frozen surfaces in endless darkness. In 2011, astronomers studying microlensing data uncovered evidence suggesting rogue planets may be incredibly common.
The findings shocked researchers, indicating these lonely worlds could rival or even exceed the number of stars. This discovery challenged long-held beliefs that planets only exist as companions to stars. Instead, it revealed a universe filled with orphaned worlds, each carrying its own untold history. But the mystery deepens when scientists consider how some rogue planets might actually support life. Without sunlight, life would need to rely on alternative energy sources hidden beneath the surface. On Earth, deep-sea hydrothermal vents host thriving ecosystems completely independent of sunlight. These ecosystems survive using chemical energy, a process known as chemosynthesis instead of photosynthesis. If similar conditions exist on rogue planets, life might thrive in complete darkness, hidden from the universe. This raises an unsettling possibility that life may be far more common, yet far more hidden than we ever imagined.
Entire biospheres could exist beneath icy shells, completely isolated from stars, evolving in silence over billions of years. But if life exists on these worlds, it would never see a sunrise, or even know what a star is. Their universe would be defined entirely by darkness, pressure, and the faint glow of internal energy.
And yet, these hidden worlds may be among the most stable environments for life in the entire galaxy. Unlike planets orbiting stars, rogue worlds are free from solar flares, radiation bursts, and catastrophic stellar events. This isolation could allow life, if it exists, to evolve slowly, without sudden extinction-level disruptions from nearby stars. However, that same isolation also means these worlds are nearly impossible for us to explore directly. Traveling to even the nearest rogue planet would take thousands of years with current technology. And without a nearby star, navigation and communication would become incredibly difficult in the endless void. Yet, despite these challenges, scientists are already imagining missions to intercept these wandering worlds. One idea involves using advanced propulsion systems to match the speed of a rogue planet drifting through space. Another concept suggests sending autonomous probes that could survive decades of travel in complete darkness. But even if we reach one, landing on a rogue planet would present entirely new challenges never faced before. With no sunlight, temperatures could plunge far below anything experienced on Earth, freezing most materials instantly. Any exploration would require drilling through kilometers of solid ice just to reach potential liquid oceans below. And even then, we would be entering an alien ocean, completely cut off from the rest of the universe. No sunlight, no sky, no horizon, just endless darkness stretching in every direction. If life exists there, it may look nothing like anything we have ever seen on Earth. Creatures could rely entirely on chemical signals, heat gradients, or faint electrical currents to survive and communicate. This challenges our definition of life itself, forcing us to rethink what conditions are truly necessary for biology. But rogue planets are not only fascinating, they are also potentially dangerous on a cosmic scale. A wandering planet passing too close to a star system could disrupt orbits and trigger catastrophic gravitational chaos. In extreme cases, such encounters could eject planets, collide worlds, or even destabilize entire systems. This means rogue planets are not just silent wanderers, but potential agents of destruction moving through the galaxy. Astronomers have even wondered if a rogue planet could one day pass through our own solar system unexpectedly. Such an encounter could subtly alter planetary orbits long before we even detect its silent approach. But detecting a dark, cold object before it gets close would be incredibly difficult with current technology. This raises a chilling question about how many rogue planets may have already passed near us unnoticed. Some scientists even speculate that past mass extinctions on Earth could have distant cosmic triggers we don't fully understand. While there is no direct evidence linking rogue planets to such events, the possibility remains scientifically intriguing. Beyond danger, rogue planets may also hold clues about how planetary systems form and evolve across the universe. Each rogue planet carries a history written in its composition, orbit, and internal structure. By studying them, scientists can reconstruct the violent past of distant star systems billions of years old. They are like cosmic fossils, preserving evidence of processes we can no longer directly observe. Some rogue planets may have once orbited stars similar to our Sun before being cast out into darkness. Others might have formed alone, collapsing directly from gas clouds,
without ever having a parent star.
These free-floating planets blur the line between planets and failed stars known as brown dwarfs. Understanding this distinction helps scientists classify objects and refine models of cosmic formation.
The more we study rogue planets, the more we realize how diverse and unpredictable planetary systems truly are. No two rogue planets are exactly alike, each shaped by unique events in its distant past. Some may carry thick atmospheres that trap heat, creating conditions warmer than expected for such isolated worlds.
Others may be completely frozen solid, their interiors slowly cooling over billions of years. Together, they form a hidden population of worlds that may redefine our understanding of the universe itself. And just when it seems we understand them, rogue planets reveal even stranger possibilities hidden within the darkness.
Some researchers suggest that thick hydrogen atmospheres could trap geothermal heat, keeping entire surfaces unexpectedly warm. In such conditions, liquid water might exist directly on the surface, even without any nearby star. This challenges the traditional idea of the habitable zone, which depends entirely on a planet's distance from a star.
Instead, habitability may depend on internal heat, atmospheric pressure, and chemical energy, rather than sunlight alone. If true, the number of potentially habitable worlds in the universe could increase dramatically beyond current estimates. But proving this theory requires observations far beyond the limits of today's telescopes and instruments. Next-generation observatories, like space-based infrared telescopes, may finally detect the faint heat signatures of these worlds. These instruments could reveal rogue planets not through light, but through the subtle warmth they emit. With each technological breakthrough, the invisible population of rogue planets becomes slightly more visible to us. Yet, even as we begin to find them, their true nature remains one of the greatest mysteries in modern astronomy. Are they barren, frozen wastelands, or hidden sanctuaries where life quietly thrives beyond our reach? The answer may redefine our place in the universe and what it truly means for a world to be alive.
Because if life exists in these dark worlds, then the universe may be far more alive than it appears. And if life can exist without sunlight, then our understanding of biology itself must evolve. Rogue planets force us to confront a universe where darkness is not the absence of life, but a different kind of beginning. They remind us that what we cannot see may be far more important than what we can. In the vast silence between stars, entire worlds may be evolving, changing, and surviving in ways we barely understand. Each one is a story waiting to be discovered, a mystery drifting endlessly through space. And perhaps, somewhere out there, one of these lonely worlds is not so lonely after all. Imagine standing on a rogue planet's surface where no sunrise ever comes and the sky remains eternally black. Above you, there would be no sun, only distant pinpoints of light scattered across an infinite void. The ground beneath your feet would be frozen solid, possibly hiding a vast ocean kilometers below. Every step would echo in silence as sound struggles to travel through the thin or non-existent atmosphere. The cold would be relentless, pushing the limits of any material or life form attempting to survive on the surface. Yet, beneath that frozen shell, an entirely different world might exist. Warm, dynamic, and possibly alive. This hidden world would never know the stars, existing in complete isolation from the universe above. Its creatures, if they exist, would evolve without sight, relying on senses we can barely imagine. They would never witness a galaxy, never feel sunlight, and never understand the vast cosmos beyond their world.
And yet, their existence could be just as rich, complex, and meaningful as life on Earth.
This realization forces us to rethink the idea that light is necessary for life to flourish. Instead, life may simply adapt to whatever conditions the universe provides, no matter how extreme. Rogue planets become a symbol of resilience, proving that even in darkness, existence can find a way.
They also remind us how little we truly know about the universe and the hidden worlds within it. For every planet we discover, countless others remain invisible, drifting silently beyond our detection. The universe may be filled with more darkness than light, yet that darkness could be full of unseen possibilities.
Rogue planets challenge our perception of loneliness, suggesting that isolation does not always mean emptiness. They drift endlessly, carrying secrets across the galaxy, waiting for a future civilization to uncover their mysteries. Until then, they remain silent witnesses to the universe's history, moving through space without purpose or destination. And somewhere in that endless darkness, a lonely planet may be holding the answer to one of humanity's greatest questions.